So far in this chapter, we've talked about graphing. We've talked about slope on Thursday last week and doing a lot of different things with slope. And this is going to kind of tie both of those things together a little bit. Our focus today is going to be writing linear equations. So for right now, we're only worried about linear. We're not going to worry about like quadratic or anything like that. So we just need linear equations and being able to write them in different formats. And we're going to talk about really two different formats that we're going to write them in. The third one, maybe we can talk about a little bit, which is point slope form. But as we get further and further along, we don't use point slope quite as much as we used to. Slope intercept's the big one, and then standard form just a little bit. Okay, the one that we have seen a lot so far in this chapter, the first two lessons that we covered last week, we talked about slope intercept form. And we said M always represents the slope, B always represents the y-intercept. So in order to write an equation in slope-intercept form, if I knew what those two things were, then I would be able to write an equation pretty quickly, pretty easily. For instance, if I said I have a slope of 1/4, and I have a point as 0,5. Now the part that makes this maybe not necessarily difficult, but they don't just come right out and say, hey, here's my y-intercept, right? But where is the point 0,5 at? If I were to graph it. 5 up on the y-axis, right? And the y-intercept is just that. It's the point that's on the y-axis, right? And when you have a line, there's only one point that will fall on the y-axis, okay? And that's the point. So even though they don't just come right out and say, hey, here's my y-intercept, 5 is the b value. And we know that because x is 0. If x is any other value other than 0, then that won't work. But here we know that x is 0, so b is 5. So my equation would simply just be y equals 1/4 x plus 5. Okay, another one would be one like this. Okay, it's nice when they just come right out and say, hey, here's our slope. This one doesn't do that. Okay. But when I look at those two ordered pairs, what's one thing I can identify really quickly? The y-intercept, right? My y-intercept is 2, right? Because my x value of 0, this is going to go up 2 on the y-axis, so we would have a y-intercept of 2. Okay, and then we're going to go y2 minus y1 over x2 minus x1. That's what we talked about on Thursday, and I know it's been a couple of days, but that's our slope formula. Anytime we're given two ordered pairs, we can always use the slope formula to find out what that slope is. And it doesn't really matter which one of these is x1, y1, and which one's x2, y2. So I'm just going to go ahead and label those x1, y1, x2, y2. And we're going to go 4 minus 2 over 3 minus 0. Which gives us 2 over 3. And that's our slope. If it reduces, we would reduce it. It does not, so we just leave it as 2 over 3. And then we would write our equation as y equals 2/3 x plus 2. And that would be our equation in slope-intercept form. Okay, so that's where some of the things that we did last week are going to keep tying in to what we do today and through the rest of the week. using the slope, finding the slope, using the slope formula or doing it off of a graph, all different skills that we got to kind of remember from last week. Okay, another one here I'm going to put up here, and I'm going to show you how to do this one two different ways. And I don't always show you two different methods of doing everything, but the reason I show you this here is because you've probably been familiar with doing this one way in the past, and as we go throughout this chapter, sometimes we will still use what we call point slope form. And the other one, we're only going to use slope intercept form. And the reason I show you the both is because if they ever ask me to leave my answer in point slope form, I'll show you what that looks like. But the majority of the time, slope intercept form is going to be our go-to. That's going to be the form that we're going to leave it in. And that's the form we're going to see the most of. Okay, this is a little bit different because we know the slope and we know just a random point that would be on this line. Yeah?
Is it an I or a 1?
Up here?
Yeah.
It's a 1.
Okay.
Yeah. Sometimes I don't know what goes on with my pen, but it like kind of puts a gap when I draw, or I kind of. What's that? Blame it on the pen. Okay. So 3-1 is, yeah, you're glad that we're not dealing with ice?
Yeah.
Yeah. Hey, the good thing about intermediate algebra is we don't talk about imaginary numbers. So you don't have to worry about it. Can't say the same for college algebra if you take college algebra, but intermediate algebra, no worries. All right, so m equals 2, and I have a point at 3-1. I don't know the y-intercept, right? And so I can't just look at this and say, boom, there's my y-intercept. So we're going to use our slope, and then we're going to use this ordered pair. And I'm going to label that ordered pair as x and y, okay? Because that's what our ordered pair always is an x and a y. The only thing I don't know in this equation is b. B is our unknown, right? And that's what we're trying to find here. So we're going to plug all three of those things in to that equation. My y value is 1. My m is 2. My x is 3 plus b. And then we're just going to solve that equation for b. And we're going to subtract 6. And we get b equals -5. And that would be our slope-intercept form. Okay. And there's really no way that I can just look at this information and say, oh yeah, my y-intercept is -5, right? So we got to do a little bit of work to be able to get there. Hey, as we said here, this one is what we call point slope form. You've seen it before, but we haven't done it yet this year. Okay, so that's going to be something a little bit new. And typically, we use point slope when I'm given just that. When I'm given a point and I'm given a slope. Okay, I'm given those two things here. So that's the other reason why I'm showing you this, is because the name pretty much tells you that you should go to use this one. But slope-intercept form really is not that bad to use here. So it kind of depends on how you're leaving your answer and how you're supposed to write your answer as to which one of these I'm going to use. So on this one, we're still going to use the same information. Slope of 2 and a point of 3-1. Okay, on this one though, we're going to label this ordered pair as x1, y1. And we're not going to put anything in for the x and the y. We're going to put it in for x1 and y1. So we're going to go y minus 1 equals 2 times x minus 3. This right here is our point slope form. If they ever ask us to write an equation in point slope form, we're done. That would be how we're gonna leave it, okay? But I wanna show you really quickly that if I had to go to slope intercept, if I had to go to this and I was here right now, I could really easily change this into slope intercept form. And what we would do is we would distribute first. And then I would add 1. And if we notice then that the two answers are the same. Okay, so it's a little bit different way of getting there. What's really going to matter is how are we going to leave our answer? Are we going to leave it in point slope or are we going to leave it in slope intercept? Majority of the time, slope intercept is going to be our go-to. And so that's why I show you how to get there. If you were going to put an equation in slope intercept, how many of you would go the one on the left versus the one on the right? Is there anybody that would like to use this method more? And I kind of show you this because in the past, a lot of people kind of like this method. Maybe kind of depends on how you learned it or whatever, but I think we're kind of moving away more and more away from it because slope intercept form is probably used more than point slope on anything that we do, especially as we get up into some of the more upper level, like algebra 2, you don't really use point slope form much. Maybe a little bit more in algebra 1. Okay. But a couple different ways that we can get there. So if I gave you one like this, and I said, let's put this into slope intercept form. Let's write our answer in slope intercept form. You don't have to do both methods, right? So everybody kind of agrees doing the one on the left from the last one's probably the way to go? Just strictly go slope intercept form, not even deal with point slope? Even though that's what we're given, right? We're given a point and a slope. So that's another reason why sometimes people think, well, I got to use point slope because that's what I'm given, but not necessarily. Okay? So this is my x. This is my y. So we're going to go 3 equals negative 3 halves times negative 1 plus b. Okay? And I kind of picked this one out for a reason because as we solve this one out, negative times a negative make this a positive 3 halves plus b. And I'm trying to get b by itself. And oh my gosh, we have a fraction. Not a fraction again, right? Dang fractions. Why do we have to have fractions, right? But we got it, so we got to deal with it. So 3 halves, I got to get b by itself. What are we going to do to get rid of the 3 halves? Subtract it, yeah. So we're going to subtract 3 halves from both sides. So 3 minus 3 halves. If I needed a common denominator, 3 is really 6 halves, right? I could multiply 6 divided by 2 is 3. I multiply by 2 on top and bottom. So 6 halves minus 3 halves would be 3 halves. Or 3 minus 3 halves would be 3 halves. Or if you wanted to do a decimal, decimals would be okay too. You could do 1.5. And you should, I mean, can you use your calculator to do that? Without a doubt, okay? I don't really limit you on things like that. But make sure your answer makes sense sometimes too, because sometimes we get an answer and like, does 3 halves make sense or not? In this case, it would. And so we're going to say y equals negative 3 halves x plus, and then you could either go 3 halves or you could go 1.5, whichever way you'd want to do it. Okay. Typically, slope, we don't write it as a decimal. We don't really want to write slope as a decimal in most cases, okay? The y-intercept, you could probably do it either way. If I was graphing this one, which we're not going to do a lot of graphing today, but if I was graphing this one, it would be a lot easier to graph using a decimal than it would fraction. So it kind of depends on how you're using it and what you're doing with it as to what we're going to do and go. Okay, a couple of other things that we're going to do here. If I had negative 5, 0, and 0, 6, once again, we're going to write our answer in y equals mx plus b form. On the last couple of problems, we were given the slope immediately, and so then we have to be able to write the equation, right? And on this one, we don't have the slope, so we got to find the slope. So we're going to go 6 minus 0 over 0 minus negative 5, which is really 0 plus 5, which is 6/5. Okay, do we know the y-intercept? Or do we have to find the y-intercept? I have 2 points given to me. Are either one of those points the y-intercept? Okay, which one? Where's this point going to be? If I graph this, where would it be at? Left 5, right? If I graph negative 5, 0, this touches the x-axis. Right? So that would be the x-intercept. Negative 5, 0 is what we call the x-intercept. 0, 6 is on the y-axis. So that would be my y-intercept. And just understand what's going on here today, guys. Like last week we talked about graphing this, right? Connecting those 2 points together to make a line. We're just writing an equation for this line, is all we're doing. Okay? My slope is up 6 over 5. There's my slope. My y-intercept is negative 6. So think about what the graph would look like, right? And remember, if I have an x value of 0, that is my y-intercept. Okay? So we don't have to go plug it in or anything. We immediately know what our y-intercept is here whenever I see that, especially x equals 0. When I see x equals 0, I know that is my y-intercept. And that would be it. Okay. But now we're going to do something a little bit different. There's going to be a couple of problems today where they're going to ask us to write it in standard form. So standard form takes a little bit more work. Standard form has a couple of things. First of all, A, B, and C don't represent slope or y-intercept or any of those things. A and B are just numbers. A, B, and C, I should say. A, B, and C are all integers. Whenever I turn this light on in the morning, like it blinks like during this hour and then it's fine the rest of the day. So it's just your guys' hour that it does that all day, all hour. And then I guess it warms up or something. I don't know what happens, but then it stops. Okay, so we're going to change this into standard form. And whenever an equation's in standard form, x and y are on the same side as one another. Okay, so what we're going to do is we're going to move 6/5 to the other side. I have fractions, okay? And when we say a, b, and c are always going to be integers, then they can't be a fraction. So what we have to do here is we have to get rid of the fraction. Well, what am I going to have to do here to get rid of the only fraction we have is negative 6/5. What would be a real quick and easy way to get rid of my fraction here? What do you think, Deja? Yeah, you're just going to multiply by 5. We're just going to take 5, but here's what we have to make sure we do. We have to make sure we multiply everything. I can't just multiply the fraction by 5. I got to do it to everything. I got to apply it to the entire equation. So what's going to happen here is when I multiply this by 5, the 5's are just going to disappear, okay? And that would give us a negative 6x plus 5y equals 30. Okay, one last thing. A must be positive. Whenever you finish up in standard form, we always want the a value to be positive. And so what we're going to do is basically multiply by negative 1. But when I multiply by negative 1, all that does is switch all my signs. So this becomes 6x minus 5y equals negative 30. And that's our standard form. Okay, so there's going to be a few problems today where they're going to ask you to do slope-intercept, and then we're going to change it to standard after that. Okay, this one is just a little bit more work. Because if I ask you to do the same thing, we're going to put this, bless you, in y equals mx plus b, and then we're going to put it into standard. So we're going to do the same thing we did on the last problem. We're going to put it into those two forms. We always want to go to y equals mx plus b first. Okay, do I know my slope? Nope. Do I know my y-intercept? No. How do I know that neither one of these are my y-intercept? Because they don't have an x value of 0, right? They're neither one of those. If I plotted those 2 points, they would just be sitting out in a quadrant somewhere. They're not on the y-axis. In order to be the y-intercept, it has to be on the y-axis, which means we'll have an x value of 0. Okay? So we should be able to look at that immediately and say, I don't have either piece of information that I need. So my first thing is do our slope formula. y2 minus y1. Make sure y's are on top. So 3 minus negative 1. And then 2 minus 4 is negative 2. So we get a slope of negative 2. So that's our m. We still don't know b. Okay? So now I have a choice to make. I can either use this ordered pair or I can use this ordered pair. If I had to choose between those two ordered pairs, which one am I probably going to use? The one with or without the negative? Without, definitely. Okay, if I had to choose, I would use 2, 3 exactly because it doesn't have a negative in it. Negatives tend to help make us make more mistakes, right? So we're going to try to make it as easy as possible. So I'm going to choose the point 2, 3. And I'm going to use the slope of negative 2 that we just found. And then I'm going to do it like we've done the last couple of problems. 3 equals, because this is x and this is y, negative 2 times 2 plus b. Add 4, and we get b equals 7. Okay, so that is my first answer. That is our slope-intercept form, y equals mx plus b. Okay, now we're going to change it to standard form. What would I need to do to change this into standard form? Plus the 2x, you bet. So we're going to add 2x to both sides. Okay, and guess what? We don't have any fractions this time. A is already positive, so we're in good shape. This one was really easy to put into standard form. We didn't have much work to do. Just had to move the x over, and we're there. So just kind of depends on the numbers that you have, and sometimes, unfortunately, there'll be fractions, and that's just the way it goes sometimes. But those are the two things that you got to remember. X and y must be on the same side, and you always want to finish with a being positive when you're done. All right, last thing for today. If I give you these two ordered pairs, 2, 5, and 2, -3. We could do our slope right away, but here's what I want you to kind of at least visualize or see here. 2, 5 is here. 2, -3 is right here. If I connect those two together, there's my line. Okay, and what do we notice about that line? It's vertical, right? And we can always tell that a line's going to be vertical if the x values are the same. In this case, I could just look at those ordered pair immediately, and I could say, okay, they both have an x value of 2. So whenever my x value is the same, what's the slope of a vertical line? Undefined, every time. Okay, anytime we have a vertical line, my slope is always undefined. Okay, so this one's a little bit different because I can't say y equals undefined x. That doesn't make sense, right? That doesn't mean anything if I put that into an equation. So we can't write the equation in slope-intercept form like normal, so we have to write it a little bit differently. Well, this one's a little bit easier because it crosses the x-axis at 2. All I have to say here is x equals 2. That's the equation for a vertical line because all of my x values are 2. And I can see that right from the beginning. Bless you. When I see x equals 2 and my x values are the same, immediately I know that's an undefined. You don't have to graph it. I'm just doing that so you can kind of see what's going on here. So we know it's an undefined slope. So we know the equation is x equals 2. And the other one that's very similar to that would be one like this. If I were to graph this one, (3, -4), 7, -4), this one is a horizontal line, okay? Horizontal lines and vertical lines are not the same thing. What kind of slope does this one have? Been a couple days since we talked about it. Horizontal lines always have a slope of 0. Yep, every time. So here our slope is 0. So when I write my equation here, I could do this. I could say 0x minus 4, right? Because 0 is a number as opposed to undefined, but I don't really need the 0x. There's no sense in putting a 0x in there. So I could just get rid of the 0x part, and I could just say y equals -4. So the trick here is essentially looking at your ordered pairs at the beginning. If I see my x values being the same, then I'm just going to say x equals 2. If I see my y values being the same, I'm just going to say y equals -4. Okay? If neither the x values or the y values are the same, then we're going to have a different slope, and then we got to do all the work that we've done. Okay? So ones like that should be pretty simple. Like I said, you don't have to do the graph. You don't have to do all the things we did. I just wanted you to see and kind of get a visual of what's happening so you know that, okay, this makes a horizontal line or it makes a vertical line, and we kind of review what the slope is for those, right? Because that's a really, really big deal. We got to understand the difference between 0 versus undefined and how that works with writing an equation as well. Okay, you can kind of see why I split this up into 2 days, because we're not even done with 3.3, and we talked about a lot of stuff already today. Writing equations, for a linear function is there's a lot of stuff that goes into it. Okay, so for day one today, okay, and that's just for today. Make sure that you read the directions carefully. I was going to open up here real quick to kind of go. The first one, you're just writing it in slope-intercept form. Pretty straightforward because they give you the slope and they give you the y-intercept. Then you're going to do it from a graph. So you're going to look at the graph and you're going to find the slope and the y-intercept. Then you're given 2 points. Once again, slope-intercept form. So all of these you're leaving in slope-intercept form. When you get to starting at number 33 is when they're asking you to do the 2 parts. Part A is slope-intercept form. Part B is standard form. So make sure you do both A and B when you get to those. Okay, I'm going to let you guys work. If you have questions, let me know.